Hello, my Algebra 2 students. So we're going to take notes today on the quadratic formula. So the context of using the quadratic formula is finding the roots of a parabola. Now the roots are the x-intercepts, and we know that at the x-intercepts, y equals 0. Now there's two ways that you can find the roots of a parabola, and one of them is factoring. We will be doing more with factoring a little bit later, but I'm going to concentrate on the quadratic formula more in this video than on factoring. If you can't factor a quadratic form, you can't factor it, you can use the quadratic formula. However, I am going to tell you that if you forget that you can factor and you use the quadratic formula, you will still get the same answer. So technically, you can find the roots by just using the quadratic formula if that's what you want to do. Now the quadratic formula should look familiar. You saw it in Algebra 1. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember that where we get a, b, and c from is from the equation. So the coefficient of x squared is a, the coefficient of x is b, and the constant by itself is c. So let's say we had the parabola y equals x squared minus x minus 6. If we're trying to find the roots, we're trying to find the x values when y equals 0. So I'm going to substitute in y equals 0. Well, 0 equals x squared minus x minus 6. Now for this one I'm going to say, can we factor? It's going to be my first question. This would be a diamond problem. I'm trying to figure out two numbers that multiply to negative 6 and add to negative 1, and I actually can find those numbers. That would be negative 3 and 2. So if I factored this, don't forget your 0 equals, I would factor it and it would say x minus 3 times x plus 2. If you have two things that multiply to 0, one of them has to be a 0. So you can break this into two parts that say either the x minus 3 is the 0 or the x plus 2 equals a 0. And if you solve them both, you get x equals 3 and you get x equals negative 2, which means that if you were to graph this, this parabola crosses the x-axis at 3 and at negative 2. Something else, if you remember, we looked at our quadratic formulas, and since a is positive, it would be moving up, so my quadratic formula, or my parabola, would look something like that. But those are the roots of that parabola. Okay, we're going to try another one. Y equals 4x squared plus 2x minus 1. So I'm going to say I'm trying to find the roots, so I'm going to make y equals 0, 4x squared plus 2x minus 1. If I tried to factor this, it's not going to work because I can't find two numbers that multiply to negative 4 while adding to 2 at the exact same time. So we are going to use the quadratic formula. In this problem, a equals 4, b equals 2, and c equals negative 1. So if I substitute my values into the quadratic formula, it's negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I put my numbers in where a, b, and c belong. Then we're going to do some simplifying. So we have x equals negative 2 plus or minus. Now let's figure out what's underneath the square root. 2 squared is 4. I'm going to do some work on the side. Then negative 4 times negative 1, right there, is negative 4 times 4 is negative 16 times negative 1 is plus 16, which means the number underneath my square root is a 20 and over 8. Now 20 is not a whole number. The square root of 20 is not a whole number. However, if you do remember simplifying radicals, 20 is 4 times 5, and the square root of 4 times the square root of 5, you can separate those out. So you would have negative 2 plus or minus, the square root of 4 is 2 root 5 over 8. So it's another form. I'm going to show you one more thing you can actually do with this. You can reduce everything by 2. So if you divided everything by here by 2, you would actually have -1 plus or minus the square root of 5 over 4. All of those are equivalent, and we will be reviewing that a little bit more, but if you can at least get to this point right now, that's exactly where I need you to be. Okay, we're going to try this one more time. So if we have, I'm actually going to move this really quickly, otherwise I'm going to run out of space. So if we have this problem right here, we have a equals 2, b equals 5, and c equals -12. So I'm going to make y 0, so 0 equals 2x squared plus 5x minus 12. And I'm just going to put it into the quadratic formula. So x equals -b plus or minus the square root of, why did you do that? Plus or minus the square root of b squared minus 4a and c. So, all over 2a. So we now have x equals -5 plus or minus. I'm going to do a little bit of work from the inside. So 5 squared is 25, and 4 times 2 times 12 is 96. Now that since there's two negatives, you end up with plus 96. And 25 plus 96 is 121 over 4. 121 you can actually take the square root of. So x equals -5 plus or minus the square root of 121 is 11 over 4. So this problem, if I had tried, I could have factored it. Since I have a whole number, I could have factored it. But let's just say I didn't feel like factoring it. I can still use this. We are going to find the two answers. So the first thing that we're going to do is we're going to do the plus version. So first the plus version. So -5 plus 11 is 6, and 6 over 4 reduces to 3 over 2. Okay, now the minus version. So if we do the subtraction instead, so 5 minus 11 is -16 over 4, and -16 over 4 is -4, which means that our roots are at 1.5, 0 and -4, 0. Now, not all parabolas have two roots. They can have one root, they can have no roots, they can have two roots. And the part that tells you how many roots there are is called the discriminant. So we're going to fill this little table in. If you need to, pause the video right now to write this down. Now the discriminant is the number underneath the square root. It is the b squared minus 4ac. If that discriminant, the b squared minus 4ac, is greater than 0, then you're going to have two answers. It's going to be like -b plus or minus whatever the square root is, and -b minus whatever the square root is. So that means there's going to be two roots. So an example graph is it's going to cross the x-axis twice. If the discriminant is less than 0, then there are 0 roots, or also known as two complex roots. They're kind of imaginary. We will be getting into that a lot more, and it's because if numbers less than 0 are negative. So if you took like the square root of -4, you can't actually take the square root of -4. Just a little preview, we'll be getting into that later, but negative numbers, the square root of 4 is 2, and we call it I. It's an imaginary number. It's imaginary. We do imaginary stuff in math. So typically we say that there's no roots because you can't take the square root of a negative. We will get into the complex or imaginary roots later. Those are the ones that don't cross the x-axis. So they might be above or they might be below. Now if x equals 0, then adding or subtracting 0 doesn't do anything, so we end up with just one root, and that is when your vertex is on the x-axis. So for the discriminant, you can actually know how many solutions there's going to be before you even finish the problem. Whether it is greater than 0, there's two roots, less than 0, there's no roots or two complex roots, imaginary, or it equals 0 and there is one root. We will be practicing this more later. Bring your questions to class. I will see you on Monday.